Whether you are routing with a bushing and a straight bit, various types of bushings for this kind of routing, whether you're using a top bearing bit or a bottom bearing bit, whether you need a exact width dado or some mortises for loose tenons, or the perfect hinge mortise, these ugly but accurate jigs do the trick. Let me start with a hinge mortise. They can be the most frustrating and they show, so getting a great routed one that fits the hinge tightly is a nice thing. What I generally do with all of these jigs is, using hold downs on my table saw, I raise the table saw blade through a piece of plywood, whether it be 3/8 MDF, 1/4 inch plywood, 1/2 inch plywood, scrap plywood laying around. The beauty of this method is you get a straight line that's perpendicular with the edge of the plywood. In the case of a hinge mortise, all you have to do is accurately mark the width of the hinge onto the jig. The 90-degree line that I've just cut earlier will stay 90 degrees with those hinge edges. Then you, using the fence of the table saw to cut these two lines 90 degrees with the world and perpendicular with each, or parallel with each other, you simply just use the table saw fence. If you've marked your lines accurately, tap up the saw and slide it in, and you've got the perfect hinge jig. The beauty of every one of these jigs is that these overcuts or undercuts, or whatever you want to call them, these corners that look so awful, don't matter. It's the straight lines that matter, and I'll explain that to you in a minute. So here is a hinge jig. I will test the hinge in this to make sure that I cut that jig to the proper width, and once I've done that, I know that this will be accurate. I would then clamp this up against the work and route out the hinge mortise. Let me just describe why these overcuts don't matter. So this is just a representation of those 1/8 inch overcuts, in my case 1/8 inch saw kerf on my saw. If I cut those 3 cuts and remove that piece, you can see the overcuts are there, but if you have a bearing guided bit, in this case I'm using a 5/8 inch diameter bit, and you run that up against those perpendicular lines, the overcuts in the corner do not affect the straight line motion of that bit. You would have to have a bearing that is less than 1/4 inch in diameter for those 1/8 inch overcuts to affect the accuracy of the routing. And so in this case, using that 5/8 inch diameter bit, I will get a 5/8 inch or a 5/16 inch radius corner on the hinge mortise, which matches the hinge. So in this case, I'm using this 5/8 inch top bearing mounted bit, and I will run it in the jig as shown in this illustration. Just simply clamp it to the wood or the edge of the door, whatever it may be. It gives you the perfect hinge mortise pretty much every time. Now let's look at the idea of cutting some mortises for loose tenons. Loose tenons actually give you a lot more freedom in that you're going to create the tenon yourself. So if you pick a bit and a width of tenon that matches your bit, and as long as you register the jig on the same side of the wood on both pieces that you want to join, you will get parallel lines that are the same width and the same distance from the face of the work. You then will just create your tenon to fit tightly into those mortises. So in this case, I have chosen a 5/8 inch outside diameter buffer or bushing to run in this groove. Then I simply cut that groove, again raising the blade of the saw. It gives you two perfectly parallel lines. Cut those grooves. They can be long, short, doesn't matter. You can just bust out the ends. That doesn't matter either. You cut one, use your table saw fence gauge to move the appropriate distance, cut the second line, break out the ends, mount them to some kind of a board so that you can register this mortise jig on the same side of the work. In this case, I'm using this little straight bit, this little straight bit, the blue one, and I'm running back and forth on this. This is a breadboard end that I was working on. I run back and forth on that breadboard end using a plunge router and just working my way in. Again, the beauty of this is straight lines, parallel lines, and they're parallel lines that are registered to a fence. So if I put my fence on the side of the work that matters and plunge my router in, and then put that same fence up against the other piece of work on the same face, the faces that are going to be flush with each other, or whatever kind of arrangement you want. You'll cut mortises that are dead parallel, dead equal distance from the finished work, and again, then you will just create with a planer the loose tenons that will fit into these mortises you've cut. And so in this case, again, this was a breadboard end, and you'll see the breadboard end in a moment. There are the mortises, and they were perfect. In this third example, I had to cut some dados that were exactly 9/16 of an inch wide, because I had 9/16 inch wood that was going in those slots. So since my router bit was 3/8 of an inch wide and I needed a 9/16 inch dado, I had to allow enough room in my jig for that bit to be able to move laterally 3/16 of an inch. Let me just show you the math here real quick, because you can get kind of lost in all these sixteenths. I needed a 9/16 inch final dado width. My router bit was 3/8 of an inch wide. That means I needed another 3/16 inch of lateral movement in the jig to get a 9/16 inch dado. The outside diameter of the bushing I used on my router was 5/8 of an inch. If I needed 3/16 inch of movement, then my jig had to be 13/16 wide. 13/16, you put a 5/8 inch bushing in there, it'll move laterally 3/16 of an inch. Obviously it takes the bit with it, and my 3/8 inch bit will cut a 9/16 inch dado. Here's an illustration of that might help just to see that illustrated. There's the wider jig, the narrower final dado, and the 3/16 of lateral movement. If I just run my router bit against the sides of my jig, it takes the bit with it, and I end up with a 9/16 inch dado. Here's the final jig. Let me just illustrate how I kind of arrange that in my saw. I have it held with hold downs. I raise the blade where it needs to be. I adjust my fence. I've got hold downs. I've got my miter gauge up against it, holding the exact angle. I raise my blade through the work. Then I had to move the work. If I needed a 13/16 jig and my saw blade's 1/8 of an inch wide, I had to move that jig 11/16, move the fence with it, readjust the miter gauge to hold it securely and to guarantee my angle was correct, Then I simply put the bushing in my router with a 5/8 inch outside diameter and run that up against my 13/16 jig. I know this sounds crazy, but all the math is necessary to get the accurate cut. And if I've done all that math accurately and all my measurements are trustworthy, if I run that bushing against the edges of a 13/16 wide jig, I will end up with a perfectly 9/16 inch wide dado. And in fact, is exactly what happened. I held the jig down to the work in some locations on it using just a C-clamp to keep it from scooting around. In some locations on it where the C-clamp would have interfered with the edge of the router, I simply used double-sided tape to hold the jig down. Both ways it worked perfectly. I was able to run the jig up the left side and back down the right side so that you're cutting against the turn of the blade. You don't want to do a climb cut. You want to cut into the blade of the router bit. And so up the right side, back down the left side. I did that on all four of the grooves that I needed. I ended up with exact 9/16 inch grooves. All my angles were exact, and ugly but accurate was the jig. Had four more of those grooves to cut. All I did was loosen the jig, rearranged it over the lines, holding my spacing the same, and ran the router up and down the other four locations. Once I pulled the jig off, this is what the work looked like with just a little bit of light sanding. That little tiny radius at the top you could take out with a very small chisel to make that a sharp edge, or you could round the work that was going in. In all three cases, ugly but accurate. The whole key to these is raising the saw blade on the table saw through the jig in order to get parallel or 90-degree and accurate placed cuts. Hope you've enjoyed this video. If you have, please subscribe, and thank you for watching.